Here is how to do a hypothesis test for a difference in means of independent populations, two independent populations on the Ti-84 calculator. First, we'll go into Stat, and we'll use the arrow buttons to navigate over to the Tests tab, and then we'll go down to the two-sample t-test, which is option number 4, and we'll hit Enter. We could input data or statistics. Let's say we have the statistics. So for an example problem, let's say we would like to find the 95% confidence interval for the difference in the average monthly pages read for teenagers and adults. So first, x bar 1, let's say we took a sample of teenagers and we said for 27 teenagers, we got a sample mean of 326 pages read per month with a sample standard deviation of 37.5 pages. And then with the sample size of 27, so that means N1 is 27. In the second group of adults, let's say we got a sample mean of 284 monthly pages read and a sample standard deviation of 29.9 pages and a sample size of 25 adults in the second sample. So now we're testing with the null hypothesis that the two means are equal. We have 3 possibilities for the alternative hypotheses. So this first one is that mu1 is not equal to mu2, which just would be a two-tailed test. We also have the option that mu1 could be less than mu2, or mu1 minus mu2 is less than 0, which is going to be a left-tailed test. We also have mu1 is larger than mu2, which would be mu1 minus mu2 is larger than 0, which is the right-tailed test. And let's say we don't want to pool the variances, so we'll hit no for the pooled question. Go down and hit calculate. So we get many useful values. The top 3 below the alternative hypothesis are the most important. So here we'll have the t-test statistic, 4.48, which is very high. We also get a p-value, which might look high, but we also have this e to the minus 5. So this number is times 10 to the power of minus 5. In other words, divided by 10 to the power of plus 5. So really small. So we look at the p-value, it's less than 0.001, so we'd be rejecting it at the 90%, the 95%, and the 99% confidence levels, for example. It's a very small p-value. If the p-value is smaller than your significance level, we call that alpha, then you will reject the null hypothesis. And we also get the degrees of freedom, which is a useful number. Now, what would we do if instead of having the statistics already, we just had data points? No problem, we can enter those too. So let's go into Stat, and then we're at Edit, so we'll hit Enter. And then we'll put in our data points for the first group in L1 and the second group in L2. So let's clear L1 and L2. Let's say we're wondering if gamers sleep more than non-gamers. So we have 2 samples, one of people who classify themselves as gamers and one as people who do not. So we'll put in their sleep per night data. Let's say for the gamer group, we had 8. So I skipped ahead and put in all the data for the 2 groups. Let's say we had 14 gamers and 20 non-gamers. And then we had different sample sizes, but that's okay. We can still calculate this. So then we'll go into Stat, then we'll go over to Test with the right arrow button, and then we'll go down to two-samp t-test because we don't know the population standard deviations. So we'll press Enter. Now instead of statistics, we'll put in the data points themselves, which we have in our lists. So we'll go over and hit Data, Enter. And then we'll select our lists. I already have them. This is the perfect setup, but if you did need to reference them, you just do second stat into list, which you get all the names. So I'll put in L1 as the first list. So now we didn't do frequency lists, so we'll just put 1 for each. Now let's say we wanted to test if the gamer population sleeps less than the non-gamer population on average. So we would put mu1 less than mu2 as our alternative hypothesis. Then, unless you have a great reason to believe that the population variances are the same, you would hit no for pooled. If you think they're the same, you hit yes. Then we'll go down and calculate it. And so we get our test statistic. By the way, this is fake data, but we do get a test statistic of minus 1.26, which has a p-value of 0.1086. So the data is not extreme enough to suggest that there's evidence that gamers sleep less than non-gamers on average. And we also get the degrees of freedom. Just to show you what it looks like if you draw it, because it's very cool, you would go into Stat, then the Tests tab. I can just press 4. And then if we do everything the same, but we draw it instead, you could choose any color you like, but I just picked magenta. Then it will actually draw the distribution, and you can see what is your t-value going to look like for your context. So remember, it's a left-tailed test here. So that is our t-value, it's negative, and it is not very significant. It looks like this area is about 0.1 we found out from the p-value. So we're expecting 10% of the time, if there is no difference, which we assume the null hypothesis when we do these tests, that we would get more extreme differences in our samples than we did. So we'll say at the 95% confidence level, for example, that there's not enough evidence. And this is what that looks like in a beautiful picture. Okay, great job.